All right, today my main mission is to try to teach you how to graph. And these are not super hard. They are kind of a challenge, but they're more like this than anything. You've done this a million times. Do you get that that's just a quadratic that's been moved around? How about that thing? What did that do? Left 3. How about this thing right here? Up 7. How about that thing? Stretch twice as what? Tall or wide? Twice as tall. And how about that thing? Flip, up, down, flip. Okay. Now we just have things that look like this. Y equals negative sine of x. Now let's make it 3x just to make it more of a challenge. And then it might say like, well, let's even put a 5 in front. Okay, let's say we had to graph that. Well, you really need to know how to graph sine x first, right? Just like we didn't start graphing these. We started graphing normal parabolas, and then we stretched them and moved them and stuff. We got to make sure you could actually handle plain old-fashioned sine. But once we're done graphing that, this just makes it 5 times taller. So the wave just gets 5 times taller. This flips the wave over. And this is the hardest part. That stretches it left-right, which means that basically it's going to get, in this case, it's not 3 times wider. It's going to make the wave get over with 3 times faster because it has to complete its full cycle, its full wave, but it has to do it 3 times faster than normal. I'll show you how to do that part in just a second. So for right now, let's just step away from graphing for just a second and go to the stuff that is really important for this next test that we have coming up. All right, so I'd like you to start by seeing if you can handle this one. Tangent of theta is equal to 1, and I'm going to say cosine of theta is less than 0. Then I'm going to say that I want your answer to be between 0 and 2 pi. Now that just told you a lot of stuff, but it really could have told you a little bit more if you're smart. Because if you know that 1 is the same as 1 over 1, you now know that I gave you 2 sides. And where the answer is really important, because you hopefully know that this was a big clue as to what quadrant I'm in. I'm in a quadrant where cosine is negative. All right, I'm going to give you a minute here and give that one a shot. Try it right now. You're going to have to eliminate a couple quadrants, figure out where it's got to be, and graph it, or like make the little triangle. And then what I'm really asking is, how many degrees is theta? Okay, I'm back from about a 3-minute pause there, and hopefully you had a chance to do this one. First thought, tangent is positive. No negative there. Therefore, I said tangent is positive. So you should have gone, all students take calc, you must be either here or here. Okay, so I'm ruling out this and I'm ruling out that. Now, when it says cosine is less than 0, this part right here tells me it can't be here and it has to be down there. There's only going to be one answer then. This is usually a clue that there's 2 answers, but there's only one answer. One answer is right in here. Now, when I draw this thing out, I now need to figure out the sides that were given to me. I was given sides of opposite and adjacent, because tangent, adjacent. Opposite sides 1, adjacent sides 1, and now be careful with your negatives. Are one or both of these negative? Both negative. Don't forget that, because we went to the left and down, so they're both negative. Then this is square root of 2. When will you ever have a hypotenuse that's negative? You never will. Hypotenuses are always positive. Okay? All right, so now, what did they want? They wanted a degree. What is the degrees then? Well, I recognize this one. It's a 45, 45, 90. So my answer must be 45 degrees. Wrong. It's not 45, not even 450. It's not 45 degrees because not only is it wrong because it needs to be radians, but also because the real answer is this one. It wraps all the way around from here, all the way around to there. So it's 180 plus the 45, which would be 225 if you did it in degrees. At least you'd be close then. But that's not what I really want. What I really want is radians. So why don't I count it up in radians? If I go, if I know that every set of 45 degrees is like pi over 4, have you memorized that yet? Haven't you? Should. Then this is 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, that must be 5 pi over 4. And yes, you could have gotten that by taking your 225 and multiplying it by pi over 180. And then I could do some canceling. Cancel, cancel. 45 goes in this 4 times, thank you. 45, no wait, 45 goes in there. Yeah, it is 4 times. 45 goes in there, what, 3 times? Oh, 5, that's right. That's a bigger number of times. Okay, anyway, 5 pi over 4. It's way easier to do it the other way. Just trying to show you 2 ways to get 5 pi over 4. Raise your hand if you had 5 pi over 4. Awesome, that's like 3/4 of the class. Okay, now, one more thing before graphing. There's those quadrantal kind. What if you can't draw a triangle? What if the answer ends up coming out something like this? What if I say tangent of theta is undefined? You are not going to be able to draw a triangle for that, are you? You can't say it's undefined over 1. I mean, that's crazy. But there's no sides for that puppet. So that means you must be either here, or here, or here, or here. Those are the spots where you can't draw triangles. And I've told you to use the 0 and 1 as your guide for those. And the radius will always be 1 then. So this spot right here would be what, comma, what? 1, comma, 0. This spot here would be what, comma, what? 0, comma, 1. How about over here? 1, comma, 0. And the last one, 0, comma, negative 1. Okay. And now tangent being undefined means that one of these here has got its y over x. Why am I using y over x? Because tangent of theta is y over x. Have you memorized that yet? If you haven't, you got 3 to memorize. That one, and also sine of theta is y over r, and cosine of theta is x over r. These little rules are super important. X over r. Gotta have them memorized. Remember those? Sine's y over r, cosine's x over r, tangent is y over x. Okay. All right, so then, if tangent is this one, then I must really have y over x. So undefined, it's almost like saying that undefined then is really y over x. How could that be? Only if x was what? If x was 0, then it would be undefined. You get that? The only way this could work is if that's 0. That being 0 doesn't make it undefined if x is 0. So which of my choices have x equal to 0? I just look at them all and I say x equals 0 is that one. And that one. There's 2 answers where x is 0. So therefore there's 2 answers. Pi over 2 is one of them. What's the other one? 3 pi over 2. Raise your hand if you think you could have done that one. All right, good. One more for you then. All right, I want to give you one where it's a quadrantal, and I'm going to tell you that cosine is going to equal 1. Cosine is equal to 1. And I'm also going to tell you that I want the answer to be between, here's theta, it's between 0 and 2 pi. In other words, I want it in radians, and it can't be negative. All right, try it. You won't be able to get a triangle. You get a place. This is R3 level stuff. I'm going to pause for a second when you work on it. Okay, so here's what you should have done on this one. You should have been thinking it's a quadrantal because think about this. Can cosine, which is adjacent over hypotenuse, could it possibly be that the adjacent and the hypotenuse were the same length? That doesn't happen in a normal triangle because hypotenuses are supposed to be longer than the other ones put together. Or they actually, yeah, they should be longer than the other put together. So bottom line is this and this have to be telling you that you're at a quadrantal spot. Here, or here, or here, or here. And this is at 0, 1. This is at, no wait, 1, 0, sorry. This one's at 0, 1. This one's at 0, -1. And this one's at -1, 0. Okay, which spot is it then? Well, if I know cosine, and I do, cosine is y over r. I've been told that the y and the r are both 1. Well, the way I drew my circle, my radius is 1. Yay. Now, where is the, oh wait, that's sine, isn't it? Sine is y over r. X over r. Oopsie. Sorry. Got distracted there. Okay, x over r. Okay, the x is gotta be 1 and the r's gotta be 1. The r is gonna be 1 for sure. And the x has gotta be 1. Alright, so which one of these has x equals 1? That spot. And that's it, isn't it? All I'm saying is that this spot right here kind of has an x equals 1, but it's actually a -1. -1 over 1 would be equal to -1, and that's different than 1. The radius is not -1, though. Okay, so bottom line is we have to pick this one and only this one. And so therefore, I would be able to easily agree with you that the answer is either 0 or 2 pi, but you know the really weird part is, the way I wrote the restriction, it can't be either one. And the answer is no answer. Now that would be a cruel one on the test. Okay, I would have thought, I think on the scenario like that, we first of all wouldn't have put that on the test, but if we had, we'd have said or equal to, and then we'd have accepted either 0 or 2 pi, or both. But 0 and 2 pi are the same. All right? That was a little tricky, but how many of you knew we were talking about this spot right there? Raise your hand if you did. Okay, good. All right. This is tricky, no doubt about it. We've got about 4 minutes going. We'll start the graphing part now. So, let's get to the graphing. Grab your worksheet. Let's do number 3 together. Number 3 off the worksheet. Now, you already have started it, I hope, by answering the questions like what's its amplitude and what's the period and that kind of stuff. But let's do number... Could you read me that one? Number 3. All right, 2 sine x. Well, that's just sine x except twice as tall. So this will be easy. To start with, though, I have strong advice for you. This is good for all graphing that you're going to do in the next week or so, including the test. Always start by graphing the parent one, and a lot of times you'll never even have to move it. A lot of times we're just going to renumber around the parent graph. So start by graphing the parent one right. And the 4 important spots are the first 4 notches. And they are just like they would be on this, pi over 2, and then pi, and then 3 pi over 2, and then 2 pi. Our 4 important notches are pi over 2, pi, 3 pi over 2, and 2 pi. Then graph on top of that the sine function. Sine goes up to 1, down to 0, back down to -1, and back up to 0. There's the wave. Okay, now, does it ask you to graph 1 or 2 periods of pi? It says graph only 1 period of the function. So don't just continue the wave out because you feel like it. If they ask for 1 period, only graph 1 period. All right, so I graphed 1 period. Now, I next need to change this 2 and deal with this. Now, technically, I could have you go like this. Just go twice as tall. But we're going to make it easier on you, especially when the problem becomes like make it, 7 halves instead of just 2. What if there was a 7 halves? It's going to be a real pain in the neck to try to figure out exactly how high to make it. So we're going to let you just change the numbering here, where it used to be 1 and -1. Now, what do you think I'm going to change it to? 2. Now it's going to 2 and down to -2. But if you don't change those numbers, you won't get credit. All right, so it's just the parent graph. How could this be right? Because I changed this and this. And now that shows that it has been stretched. You get that? Okay, that's it. That's the first one. Done. Let's move on to the next one. Would you read me number 4, please? All right, I strongly encourage you to think of that as 1/3 x. X over 3 a lot of times confuses kids. So you need to understand that x over 3 means 1/3 x. That'll help me a lot because later I'm going to ask what the b term is, and there it is. That's the b. Okay? So when you have something like this, just like when you had a parabola that got stretched and moved and whatever, you a lot of times started by graphing the parabola, right? And then you stretched it and moved it and everything. Same thing here. We're going to graph sine. So 4 spots. I can do this pretty fast by now. 2 pi, pi, pi over 2, 3 pi over 2. Then I go like this and make the wave. There, good. May not be perfect, but that'd be good enough. Yes. Just hold on, one step at a time. Next, I'm going to take care of this part. See that negative there? That's going to come next. Now, could I do the stretch first? Yes, I could, but it really isn't going to matter whether I do the stretch or the flip first. I'm going to check this off, my little list. I got 3 things to do, that, and that. Now, could you start on the inside? Absolutely. And I think it'd be a good idea to start on the inside, but it's the hardest part, and I really don't want to start with the hardest part. Okay, so I'm going to start with this. Negative flip. All right. Just like this. There. Now, this is one of the reasons I would strongly recommend that you use a pencil, because then you can just erase stuff when you graph the parent and you do have to erase. Okay. Would you agree we have done the negative side? Check mark, right? Okay. Next thing is this 7/4. Remember how I can just let you relabel it? So instead of going up to 1 and down to -1, it's up to 7/4 and down to -7/4. It'd be fine to use a decimal, but I wouldn't recommend it. I'd just say 7/4. It's easier. You don't have to divide anything in the calculator. Besides, I don't think you're going to have a calculator for this, because otherwise you just type it in the calculator and see what it looks like. I'm just saying, no need to do that. It's easier to just write something first. Okay, and moving on, I have check marked that. Boop, done with that. Next, the part you were talking about, and you're right, but let's make sure I understand, help people understand why. We are going to change this by making it 3 times wider. Okay, that's like stretching. If I could grab this thing that was made out of rubber, I'd grab each end of it, pull on the ends, and stretch it wider. But we're not going to make you move the graph. We're going to change the numbering. Just like we did on this way, we changed the numbers. We're going to change these numbers. So the normal period for this puppy is 2 pi. So you need to know this formula. Period is 2 pi divided by b. Remember how I said that we should use 1/3 instead of x over 3? Because 1/3 is my b term. So now I'm going to put a 1/3 right here. And this is one of those reasons we tried to weed out the kids early who couldn't handle fractions. If you can't handle dealing with flipping and multiplying and stuff, you're going to crash you. So now I got to take 2 pi, and instead of dividing by 1/3, I'd rather times by 3, and so final answer is 6 pi. So now this thing needs to get its period over with, the whole cycle over with, by 6 pi. So technically your graph should look something like this, and it shouldn't end until way the heck over there on the right. But we're not going to make you do that. We're going to say instead of 2 pi, cross it out, put 6 pi. And then think to yourself, what did you just do to the 2 pi? Times by 3. So just times everything by 3. Times this by 3, times this by 3, times this by 3. So my new numbers are 3 pi over 2, 3 pi, 9 pi over 2, and 6 pi. All right, it's lunchtime. Okay, so we're recording again here after lunch. We're going to go on and do number 5 off the worksheet that you had last night, but you never did the graphing part? All right, number 5, would you read it to me, please? Y equals cosine 7x. All right, that's a pretty easy one. It's just cosine, except it's been stretched that way, which is really a shrink. But really all we're going to do is renumber it. So to start with, we just need our 4 spots. This is why I kept saying those are so important, because every time you graph it, that's what you're going to start with. And here's pi over 2, and here's 3 pi over 2, And then cosine starts at 0 and goes, no, sorry, starts at 1 and then goes down from there. First it goes down like that, next it goes to 0, next it comes back up, and then the last it goes like that. Okay, I'm off a smidge. I'll try again. Down, and back up, there. Okay, may have went a little too low on that one, but anyways, get the point. So, that's cosine. Now, I'm not worried about these. These are going to stay normal, 1 and -1, because it's not an up-down stretch. It's a left-right stretch. So we say to ourselves, this number, what is that ever used for? It's used in this one. Period equals 2 pi over b. And what's b? 7. 2 pi over 7. There. Now, instead of 2 pi, we cross this off and we make it 2 pi over 7. And then we ask ourselves, what did we do to that? Times by 1 over 7, very good. So we times by 1 over 7 here, and times by 1 over 7 here, and times by 1 over 7 here. All right, final answer, pi over 14, pi over 7, 3 pi over 14, and 2 pi over 7. Okay, so all these are done, and they've been replaced with the new numbers. That's the hard part, is the numbering. So don't ask me, do we have to number it? Yes, if you didn't have to number it, then this would be super easy. You just leave the graph the way it was. Because it's just the sine graph in the first place. Never even moved it. Yes, you have to number all 4 of them. That is the point. That's why I'm doing that. These are the things I would be grading then to make sure you had renumbered that accurately. All right. Now, finishing this worksheet is really going to be pretty easy because there's nothing really complicated in there. And your assignment is to finish that worksheet, all of the ones we didn't already graph. Now, here's the other part of your assignment, and that is to do a few off of this worksheet. We're only going to do 1 through 8, and you're going to skip problems 3 and 4. And the reason we're skipping those will become apparent because 3 and 4 kind of got a little messed up. Their graphs appear on the back side of the worksheet where the questions are on the front side, so might as well just skip those. We're going to skip any. So again, it's 1 through 8, skipping 3 and 4. So let's start this new worksheet, and you'll find it's pretty much the same thing. Same basic thing. Once you know how to graph, it's just graphing. And remember that the test is not really about graphing. The next test you have is more about things like those quadrantals we started the hour with. That's why I didn't want to just jump right into graphing all day today, because we really don't need to graph till next week. All right, so take a look at the new worksheet I just handed out. Would you please turn your attention to number 1 on there? And would you please read me number 1 on there? Y equals? Okay, you're confusing me. Oh, that's a negative. Okay, negative for what? For what? Cosine 2x. All right. I could see making that mistake too. It is technically, it looks like what it is. It's not in the right spot for a negative. But anyway, what am I supposed to do? I'm supposed to graph cosine. Once I'm done with cosine, I got to do 3 things. That, and that. So first, just graph cosine in the 4 major spots are 2 pi, and pi over 2. And the hard one to remember, 3 pi over 2. And then cosine goes like this. Starts up high, goes down, and it's 0 down here. Comes back up, curves to the top. It's a big valley. There's my cosine graph. Then I have to make 3 changes. That one, the up-down flippage. Go like this, that, and like that. The black one is the correct one now. Okay, get rid of the parent one, the green one is gone. Okay, the next thing, after I check mark that one, is the 4. How do I make it 4 times as big? You don't actually have to stretch it 4 times as big. You just have to say that now isn't 1 anymore. It's 4. And this down here at -1 isn't -1 anymore. It's -4. Next, check, is this one. I need period of a normal one is 2 pi over whatever the b is. 2 pi over 2 just means pi. And then you ask yourself, if I'm changing this 2 pi to a pi, what did I do to it? I shrunk it. Yes. How? what do I do to each of these then? I'm multiplying by a half. That's a good way to do it. Or, yes, you can divide them by 2, but I'm going to multiply them all by a half. And 1/2 times that would be 3 pi over 4. 1/2 times this would be pi over 2. And 1/2 times this would be pi over 4. And that's the hard part, is that numbering. Otherwise, everything else is pretty easy. Yes, sir. You don't have to show this anywhere. What you do have to do is change this. Now, that's what I recommend doing, but if you got a different way of doing it, it's not a problem. As long as these get renumbered, we're going to be good. And, of course, these had to get renumbered, too, because of this. All right, moving on. Let's do one more off that sheet. Remember, I'm having you do 1 and 2, and you're skipping 3 and 4. If you haven't already crossed those off, you may want to cross off 3 and 4. And let's move on to number 5. Would you read me number 5, please? Is that it? Oh, it's just too easy. Let's skip number 5. I mean, you guys can do it because it's so easy. I don't want to take away one of your easy ones. Let's move on to number 6, though. Read me number 6. Like that? All right. 2 sine of x plus 2. All right. Now here's an important moment. Do you know that it's important that there's not parentheses right there? Because if there were parentheses right there, that would be a left-right kind of a shift. Versus since there's not parentheses right there, that's just to move the whole graph up 2 kind of a deal. You know what I'm talking about? All right. So let's graph sine, parent one. Parent one always has 4 important spots. Doink, doink, doink. 2 pi, pi, pi over 2, and 3 pi over 2. Sine kind of looks like this. It starts at 0, goes up, back down, back up again. And then I have to do this multiply by 2 part. All right, so back from a pause there, sorry. So now I have to do 2 things to it. I have to do this 2 right there. And, you know, I don't want to have to make it all twice as tall, which technically would look like this. I don't want to have to do that, so I'm going to just renumber this as a 2. And this is a negative 2. Done with that one. Okay, next thing. This plus 2. Careful now. That's not a shift to the right. If there was parentheses, it would be. That's a move which way? Up. The whole thing has to move up. Now, you can't just do that by renumbering. I have to move the whole thing up 2. Now, I'm going to do it with the wonders of technology. I'm just going to draw over the top of it and grab that and move it up 2. See, I moved it up 2 because it now touches there. But you would have done something like that, except just with your pencil. Okay? So your final answer is the green one. And no, it wouldn't dip underneath. I just happen to have, my scales are off enough that it should be touching. Okay? All right. That's all there is to it. And video's already almost 30 minutes long, so that should leave you about 15 to 20 minutes to work on this worksheet. Finish the old one. The new one, you're just doing 1 through 8, skipping problems 3 and 4. All right, that's all I got for you.